So welcome back friends. We were discussing in the previous video your experiment number 4. Moving ahead with the previous video. In the previous video we discussed your first flip-flop, which was nothing but your SR flip-flop. Today we will consider and we'll go ahead the next flip-flop, which is nothing but your D flip-flop. Okay. So in order to understand your D flip-flop, first let us have a look at your symbol of the D flip-flop, which would look something like this. As you already know, the D stands here for nothing but delay. This flip-flop produces a delay, which is used most of the times in your electronic circuits whenever you want of delay. Okay, so this is very important flip-flop, and as you can see here, it has only two inputs. One is D, which is its input, and the other one is clock, which is driving this flip-flop. So this is the main purpose or the main person you can say, which is driving this whole flip-flop, that is clock, and D is nothing but the input. Fine. You have two outputs. One is Q, and another one is Q bar. Q is the output, and Q bar is nothing but its inversion. Fine. As you know that we'll be writing this verilog code again using your behavioral description. So the most important thing we'll be interested whenever we write our behavioral description is our truth table. So the next very important thing we will see is our truth table for D flip-flop. It's quite simple, friends. It's quite simple. So when D is low, assume clock is high. When D is low, then Q is low and Q bar is its inversion, which is nothing but high. So when D is high, you can say the Q is high and the Q bar is nothing but its inversion, which is low. So it is following. Whatever the input is there, that will be the same output. It is just producing some amount of delay, keeping the whole output the same as your input. Okay. So for this, we'll be writing a verilog code. We'll just jump directly into a verilog code without wasting much of the time. So this is how your verilog code will look. I'll not go again to explain this time scale. You already know this. I explained in almost all of the videos what is time scale. Going directly into the logic of the code. So module followed by the name of the module. You can say any name you can give. No need to give such a long names. You can just write DFF. That is sufficient. Followed by you will be writing all your inputs and outputs inside this module. So we have two inputs, D and clock, and we have two outputs, which is Q and Q. Fine. So you have mentioned all your inputs and outputs here. You can just observe D, clock, Q and Q bar. The outputs are mentioned again in the form of a resistor, as we have a tradition that whenever we use our form of resistor. Next, we have a sensitivity list here, which is defined using always. So always at first edge of the clock, the whole process begins. What is the process? Quite simple. Q is equal to D. That means whatever is my input, the same must be my output. Finally, what is Q bar? Q bar is nothing but its negation, the negation of D. That's all. Okay. So end your begin, which is nothing but always, and end the module. So this finishes your D flip-flop code. To this, we'll be writing a test bench. And test bench also is quite simple. Most of the test benches for all your flip-flops remain the same, just with a slight changes. So here module name of the test bench is stimulus. We have mentioned all your inputs in the form of resistors and all your outputs in the form of wires, which we usually do. Next comes is the linking. Make sure the name of the main logic program remains the same. That is here D underscore flip underscore flop. So here also it will be the same. That is D underscore flip underscore flop. Okay. Finally, we'll be giving some instance name. Any name could be given here, F1, D1, whatever you want. It's a user-defined name. And then you'll be mentioning all your inputs and outputs. You will initialize your clock to 0 so that this could be anything. If you can just initialize your clock to 1 also, no issues. It is just the initial step. Next, you will generate the clock. How you are generating this is very simple, important. This whatever I also stressed on this point in the previous video. That is, clock must be always less than or equal to a negated clock or inverted clock. If you don't write that less than sign, you will not get a proper clock symbol. Thereby, there will be a problem in your output. Okay. Next, finally moving ahead. So here you can observe we have initialized your inputs. So the first input we have initialized is D is equal to 1. Then after some time delay, say 15 nanoseconds, we have initialized D is equal to 0 and so on. Some 3-4 initializations, or if you want to see only 2 outputs, only this much is sufficient, or only this much is also sufficient. The first two statements are also sufficient. Finally, to finish, we are given some extra 10 nanoseconds of delay. Next, you already know this is nothing but the display initial block. Here, how to display? Using your dollar monitor. Then D is nothing but it is taking your binary value, and same with the clock as well as Q and Q bar. What is this \T? It is nothing but the tab. That is when you execute in the, I'll show you again in the execution window. There you will be finding some space between the individual values. To generate that space, you are using this tab. Okay. So you can observe here, D comes first, next comes clock. So as I told you, this must be, the order must be maintained. Finally, enter the model. So we'll try to simulate it. Okay. So once you simulate, yeah. So as I was speaking, friends, so here if you come here, you can see the reason behind that tab here. You can see the reason behind that tab. The space between the individual values. This space between the individual values is generated due to that \T. Okay. So let's try to debug the output. So you can see here when D is high, clock is high. You can see Q is high and Q bar is 0. Similarly, let us try to see a value when your D is 0. So you can see here when D is 0, your Q is 0 and Q bar is high. That is, you can also see in the waveforms here. Okay. Make sure clock is also high. Finally, one more instance we can see the same thing is getting repeated. Fine. So this is all regarding your D flip-flop, friends. Again, very simple code. I hope so all of you understood it. So this finishes your 4-part B, which is nothing but the D flip-flop, which I had planned to cover in this small video. So again, we'll meet in the next video, wherein we'll try to cover you regarding your JK flip-flop. Okay. So thank you for watching. We'll again meet in the next video.